welcome to this short video where we're going to be having a look at a process known as neutralisation. Now, neutralisation actually takes place inside your body in your stomach. And inside your stomach you have an acid called hydrochloric acid, or HCl. And this allows your food to be digested, to be broken down, but also will kill any bacteria that come in on your food. But sometimes your stomach produces too much acid, and this can cause stomach pain called indigestion. Or it can cause heartburn, which is when the stomach acid comes out of the tube that leads to your mouth. What you can do though is take something called an antacid, and this will neutralise the stomach acid, and this contains something called a base, and this is something that will react with the acid in your stomach and hopefully neutralise it, bring it down to a much safer level. Now when it does this and the acid reacts with the base, these are our two reactants, you end up with two products. This is a salt and water. Now you might have heard of the acid plus alkali produces salt plus water. An alkali is basically a base which has been dissolved inside water. So if we have a look at what actually happens in your stomach when you take an antacid, the hydrochloric acid reacts with the antacid, in this case it might be magnesium hydroxide, and this will produce our salt. Now the metal from this is going to join with the chloride from this, so we get magnesium chloride, and of course we get water as well. Now if you are doing higher level science, you need to know the equation for this. So the symbol for hydrochloric acid, or the formula for hydrochloric acid, is HCl. We join this with our magnesium hydroxide, MgOH2, and that produces our magnesium chloride, MgCl2, and our water, which is H2O. We balance this out, we get 2 HCl and 2 H2O, that will balance it, and then we put in our states. So this is aqueous, this one is a solid, this is aqueous, and this is a liquid. And that's what happens. However, sometimes an antacid might contain a carbonate, and this produces a different reaction. So again we have our acid reacting with our carbonate, and this will produce a salt and water just like our last one, but also carbon dioxide. So that's our difference with this one, you get carbon dioxide being given off. So if we have a look at this in terms of an example, again we'll have our hydrochloric acid, but this time we're going to react it with calcium carbonate, and this will produce calcium chloride plus water plus carbon dioxide. Again, hires, you need to know your formula, and this will be, I'm just going to write it out for this one, 2HCl aqueous plus CaCO3 solid goes to CaCl2 aqueous plus H2O liquid plus CO2 gas. Now we can actually take our acids and our alkalis and put them on a scale, and this is known as the pH scale. Note that the P is a small one and the H is a capital letter. You don't really need to know why for that one. That's all the way up to A level that we're talking about there and beyond. And the pH scale is actually on a scale from 0 to 14, and in the middle we have our 7. If I just put our 6 and our 8 there is a reason for this. Now these are going to be our acids. These ones are our alkalis. So as we go along this scale all the way to 0, it's going to be more acidic. So here we have a strong acid, and here we have a weak acid. Here we have a weak alkali, and here we have a strong alkali. And number 7 here, this is neutral. Now when we're doing this neutralisation reaction, we're trying to get our number as close to the 7 as is possible. And you can see if your liquid is an acid or an alkali by using an indicator. Now this could be universal indicator, and it would be red down here going all the way up to yellow, up to a greeny colour here, to some blues, and then to some deep purples. Or you could use litmus paper, and litmus paper, the blue litmus paper would turn red under acid conditions, and red litmus paper would turn blue under alkaline conditions. But this must be damp to work. Now of course, neutralisation doesn't just happen in the stomach, it happens all around us under different situations. But there are 3 general equations that you need to know for acid neutralisation. So our first one is that an acid plus a metal oxide is going to produce a salt plus water. An acid plus a metal hydroxide will also do the same. It will produce a salt plus water. And if you take an acid plus a metal carbonate, this, like I said, produces salt plus water, but also carbon dioxide. Now, the salt that forms in this neutralisation does depend on the acid that you have, and you need to know what acids produce what salts. So if I took sulfuric acid I will produce is sulfate. If I took nitric acid, I will produce a nitrate, and if I took hydrochloric acid, I would have produced a chloride. Now that was a very quick run through of what you need to know for this topic on neutralisation. If you are going for higher, you need to be able to do these as balanced symbol equations as well as being able to do the word equations. But hopefully this has given you a very quick insight and has given you a refresh on what you do need to know for this topic on neutralisation. Good luck for your exams.